For our next video, we're going to look at solving radical equations. So it could be square root or it could be a cube root. It's just anything that has a radical in it. So let's start by reviewing solving other equations. I've got a linear example and a quadratic. To solve a linear, my goal is just to get x by itself. So the first thing I'm going to do, I'm going to start farthest from my x, which is this plus 3, and I'm going to subtract it. I'm just going to move it to the other side by applying the opposite operation. So the opposite of adding is subtracting. So then I have 2x equals 2. Then to get x by itself, I'm just going to divide by 2. So our goal is to slowly work our way to get x by itself, and we end up with x equals 1. For x squared equals 9. The opposite of squaring something is taking the square root. So then my answer ends up being plus or minus. You can't forget a quadratic has two solutions, so it's plus or minus 3. So you're always using the opposite operation to slowly get x by itself. The same thing goes when you solve radical equations. But our steps is first to get the radical by itself. So you're going to move everything over except for the radical and what's underneath the radical. And then you're going to raise each side to whatever the inverse of that radical is. So if it's a square root, we're going to square both sides. If it's a cube root, you're going to cube both sides. Whatever the opposite is, so whatever your index is what you're going to raise it to. So it becomes your exponent. Once you do that, your radical goes away and we can solve for x. Then you have to check for extraneous solutions. Okay, you have to plug them back in to make sure that they're not extraneous. Extraneous are just solutions that show up when you work it out algebraically, when you do it by hand, but then if you graph it, you don't actually see that solution. Alright, if you remember, our graph is a swimmer's arm, so it goes up like this. We don't include the negatives. So sometimes whenever you solve, you end up with a negative number that doesn't actually fit when we plug it back into our equation. So you always have to check for extraneous solutions. So for the first example, 3 times the cube root of x plus 2 minus 4 equals 5. Okay, the first thing I'm going to do is the same thing as if this were just one big variable, right? I would work farthest away to get closer. Farthest away from my radical is this minus 4, so I'm going to move that over by adding. Then I've got 3 times the cube root of x plus 2 equals 9. Okay, now I've got to get rid of this 3 that's out front. Well, right now it's 3 times this radical, so I'm going to divide by 3, opposite of multiplication. So I end up with the cube root of x plus 2 equals 3. Okay, I cannot do anything with this x plus 2 until I get rid of that radical. Right? I cannot take it out unless I'm going to get rid of the radical altogether. To get rid of the radical, I'm just going to raise it to whatever power my index is, which in this case is a 3. So I'm going to raise both sides to the third power. That is just going to cancel out that radical. So I'm left with just x plus 2 on this side. And then 3 cubed is 27. And now I have a simple linear equation that I can solve by subtracting 2. So x equals 25. Now we've got to plug it back in. You must check every single time. So if I plug it back in, I'm going to have 3 times the cube root of 25 that we got for x plus 2, and then a minus 4 on the outside, and that's got to give me 5. 25 plus 2 is 27. The cube root of 27 is 3. 3 times 3 is 9. And 9 minus 4 is 5. 5 equals 5, that's true. So that means that x equals 25. Okay, so first you get the radical by itself, then you're going to do whatever power to cancel out the radical, and then you solve for x, plug it back in, check for your extraneous solutions. And our second example, now I've got x minus 5 equals the square root of x plus 1. Well, my radical is by itself on this side, so my next step would just be to raise it to the power. This is a square root, so to cancel it out, I'm going to square both sides. So now my radical goes away, and I'm left with an x plus 1 on the right. Now remember, this is a binomial. I've got a subtraction in there, so I cannot distribute the square. I have to multiply. Remember, this is x minus 5 times x minus 5. So you can FOIL, or you can box, or you could just use our pattern. Remember, it's the opposite of completing the square. So I know that x minus 5 squared would be x squared minus 10x plus 25. All right? Now I've got a quadratic, all because of this x squared right here. So to solve a quadratic, I got to set it equal to 0. So I'm going to subtract x from both sides and subtract 1 from both sides. So I've got x squared minus 11x plus 24 equals 0. Okay, now I'm solving like I do any quadratic. Okay, you got 4 options. Okay, we got graphing is always an option, but we're not going to do that here. You could also do completing the square. We can do factoring. And then we could do quadratic formula, which works every single time. I can see that this one's easily factorable, so that's what I'm going to do. Now to factor a quadratic, I'm going to look for numbers that multiply to C, but add to B. I'm going to put my parentheses up. I'm going to put an X in both parentheses. And because I'm going to multiply to a positive and add to a negative, I know that both of my factors are going to have to be negative. And then I was thinking about my factors of 24. I've got 1 and 24, 2 and 12, 3 and 8. Oh, 3 and 8, they're going to give me an 11. So I'm going to have a negative 3 and a negative 8. Now I'm solving, so I need to go one step farther by setting these equal to 0, which is just going to change their signs. So I have x equals 3 and x equals 8. But I'm not done. I've got to plug them back in and make sure they work. So if I start with the 8, I'm going to plug in 8 for every x. So I've got 8 minus 5 equals the square root of 8 plus 1. 8 minus 5 is 3. 8 plus 1 is 9. The square root of 9 is 3. 3 equals 3, so that means 8 is a solution. Remember, we're only going to take the positives when we're working with our radical equations. Okay, and then we'll do the same thing for 3. 3 minus 5 equals the square root of 3 plus 1. 3 minus 5 is negative 2. 3 plus 1 is 4. The square root of 4 is 2. And negative 2 is not the same as 2. They do not equal, so that means that 3 is not a solution. It is actually extraneous. Okay, whenever we're working with radical equations and we plug it back in, we do not include the negative. So technically the square root of 4 could also be negative 2, but not in this case because we're working with a square root graph or a square root function. Okay, so you're only going to keep the positive root when you plug it back in to check.